Hello everyone, thanks for watching this video. My name is Franklin Sierra from the Universidad Industrial de Santander, Bucaramanga, Colombia, and I'm going to talk about the research work entitled An Online Deep Convolutional Polyp Lesion Prediction over Neuroban Imaging in collaboration with Yesid Gutierrez and Fabio Martinez. Colorectal cancer is the third most common cancer and the second worldwide cause of death by cancer, where 55% of patients diagnosed are male and 45% are female. Polyps are abnormal growth of tissue and they're the main biomarker for colorectal cancer. Colonoscopy is the main procedure for detect these precancerous lesions at any stages. This procedure has two modes of acquisition, white light and NBI light. As you can see in the video, the NBI light offers a greater microvascular richness. The proper identification, characterization, and classification of these biomarkers directly impacts the survival rate. Therefore, the correct characterization and classification is decisive for the clinical treatment. The polyps have a histopathological classification: adenomas, hyperplastic, and serrated. Each type of polyp has a unique cellular behavior, as you can see in the bottom row. However, the specialists must perform it in a macroscopic way. The adenoma type, carcinogenic in nature, is strongly characterized by the presence of microvascular patterns. Hyperplastic polyp, benign in nature, are identified by their smooth texture. Finally, the serrated polyp, potentially carcinogenic in nature, presents mixed characteristics of the two recently mentioned biomarkers. It's often confused with hyperplastic polyp. Due to misclassification, they register a loss of about 80% per procedure, increasing the death rate for this disease. Therefore, for the specialists, the microvascular patterns are fundamental for correct characterization and classification. However, this work is highly variable. Recent works has addressed the problem, like Zhang, who proposed a couple of neural networks to detect and classify polyps by color in their surrounding area. But within his approach, he doesn't contemplate the three types of polyps. Even more interesting, Metzejo et al. Proposed the classification of the three main biomarkers for their morphology and chromatic features. In fact, it performs a 3D reconstruction. Of the video sequence. However, due to sudden movement of camera, the reconstruction isn't very accurate. Our proposal to solve these problems: we have some NBI sequences that are mapped to a convolutional representation for each frame, and then join a probability is made between all the frames to define general class to the video. First, we have a sequence that has multiple observations of the same polyp throughout the video. We choose NBI sequence because, as you can see, they are fundamental for a correct characterization of vascular patterns. We extract frame by frame to map it a convolutional representation. To understand a convolutional representation, what was first done was take a transfer learning from a natural domain, ImageNet, to the medical domain, colonoscopy. This new transfer representation adjusts the weights to a representation of the polyps. At this point, we have a multi-scale convolutional representation. We can recognize for the different polyps certain characteristics that are potentially associated with the disease. Our CNN is so powerful that it is able to retrieve the vascular patterns for its biomarker. Then, each frame is labeled according to the highest probability obtained. This process is repeated until the NBI video frames are finished. To label the video in general, two strategies are applied: majority bounding and rolling mean. We're able to make an online prediction. The dataset used contains as main characteristic both wildlife and NBI sequence, tagged by histology. The opinion of experts and beginners. The dataset has 40 adenomas, 21 hyperplasias and 15 serrated. As a validation technique, we use Lee-one out patient out strategy. Within our approach, we work with 2CNN, BGG16 and MobileNet. To deal with the unbalanced class, we work with a customized loss function. So our evaluation and results. The first task we worked on was the classification of the three main types of polyps. Our method outperforms the baseline by 17.11% and experts by 38.16%. Even more interesting, serrated patterns are properly modeled. The second task was to analyze the behavior under an online approach, where surprisingly with only 10% of the total video, an adequate representation is achieved. As the last task was developed resection method, where the cancerous class were grouped. For this task, MobileNet architecture was used, showing promising results. Our conclusion and future work. This work introduced a convolutional polyp lesion representation that allows a per-frame classification, and outperformed state-of-the-art by 17.11%. The proposed approach was also evaluated on a resection task, showing a very promising performance. Temporal level filtering resulted in more stable prediction, and using only 10% of the videos was achieved at a Q rate of 85.22% in classification task. For future work, further analysis include the evaluation over larger datasets and loss sequence to delineate potential regions that include both adenoma and serrated polyps. Thanks for watching this video. If you want to know more about our research, you can read our paper. Bye.